For our presentation, we will be discussing an exciting technology that has been hyped for many years, but may have been oversold until now. Blockchain technology, a way to make a digital asset unique. With blockchain technology, each record or block is linked to the previous block and contains a cryptographic hash of that previous block. And what makes it so hard to change is that each block is part of a ledger that is distributed on a peer-to-peer network that gathers consensus and validates each new block or transaction. But before we get into the nuts and bolts of how this technology works, let's explore the backstory. The concept of the blockchain was popularized in the 2008 white paper by Satoshi Nakamoto that introduced the cryptocurrency Bitcoin to the world. However, this concept dates back much earlier to a 1991 paper by Stuart Haber and Scott Stornetta that tried to create a way to timestamp digital documents in a way that could not be tampered with. Working together at Bell Communications Research, Haber and Stornetta collaborated on many projects, and their research was used heavily by Nakamoto in the creation of what we know today as the blockchain and Bitcoin. Haber and Stornetta even went on to found a company that specializes in digital timestamping services called Surety. It is described by the Crypto World Index as the first commercial blockchain provider. Today, Stornetta has left the world of crypto behind to teach high school algebra in New Jersey, while Haber started a cryptographic blockchain consultancy. And that is all the biographical information that we will have today, because the next character in the story is an enigma. Picking up on the research of Haber and Stornetta, a person or persons by the name Satoshi Nakamoto published the paper Bitcoin, a peer-to-peer electronic cash system, in October of 2008. We don't know who Nakamoto is. The picture on this slide is actually a cartoon of a man that was thought to be Nakamoto and shares his name. His name is Dorian Prentice Satoshi Nakamoto. But although Satoshi Nakamoto is his given name, he is denied being the Nakamoto behind Bitcoin and blockchain. Several others have been thought to be Nakamoto, but nobody can say for sure who he is, and he has not posted any communications online since 2014, when he broke a long period of silence to say that he was not, in fact, Dorian Nakamoto. So what is the problem that the concept of blockchain was created to deal with? It's called the double spending problem. Basically, when an individual has a digital asset and he's going to trade that asset for a good or service, what is stopping him or her from sending a copy of that asset to two different merchants at the same time? This isn't a problem with physical currency, like a dollar bill or a bar of gold, but things are trickier with digital currency because digital files can be copied. And that trickiness is compounded without a central authority like a bank to resolve these disputes. Without the central authority, transactions are broadcast to all nodes or computers running the ledger software on the network to confirm the transaction, which is the basic function of the blockchain. The blockchain provides a way of communicating the transaction to all nodes on the network for their approval, so the network confirms the transaction is valid. And since every node has a transaction history, and every block has a transaction history, any attempt to make a new transaction with that asset that was previously spent would not be confirmed by the network. There are several ways of potentially working around the solution to the double spending problem, but most will only work with sellers that do not wait for confirmation, or the methods are too expensive to be worthwhile. The most straightforward of these attacks is a race attack, where a buyer works with a merchant that delivers goods or services prior to confirmation of the transaction by the network. In this attack, the buyer creates a transaction, then races to create another one once the good or service is delivered, but before the transaction is confirmed by the network. Once these transactions come back as invalid, the merchant will be out of luck since he has already provided the good or service to the buyer. The next attack is a Finney attack, thought up by Hal Finney, the first person to receive a Bitcoin transaction. This attack is similar to the race attack, but the buyer mines a block first, but does not broadcast it to the network. Then, when the transaction between the buyer and merchant is being confirmed, the buyer broadcasts the mined block, and it takes precedent over that transaction. The next attack, a Vector 76 attack, is a combination of the race attack and Finney attack, but it requires the attacker to sacrifice a block, relaying it only to the attacked merchant or node, and then it becomes invalid. Finally, a majority attack requires the attacker to control a majority of the network hash rate, generating a fork after the transaction with the attacker that is no longer the honest fork, and thus the agreed upon hash. As you can imagine, this is a very expensive attack, and on a widely distributed network is almost impossible.
What is blockchain? The structure of blockchain can be best summed up as an immutable record of transactions that do not require reliance on an external authority to validate the authenticity and integrity of the data. Blockchain is made up of a sequence of blocks that are linked together and distributed amongst all users. Each block contains data typically associated with financial transactions, but any type of data can be used and can benefit from this type of technology. There are a few key concepts that make up the structure of blockchain. First, the cryptographic hash. All input data is transformed by an algorithm into a fixed length of numbers, and every input produces a different output. The results are deterministic, so any input data will output the same hash, but these data conversions are one way. You can't reverse the hash function to find out the original input. The hash function is also used to create a unique identifier for each block of data, and each subsequent block of data includes a reference hash to its predecessor, except for the first block of data called the genesis block. The second concept is the immutable ledger. Building upon the hash concept, this feature preserves the integrity of the data by making modification of the data basically impossible. Once data is received by the chain, it can't be retroactively altered. Since each block has a unique identifier and a hash that is tied to the previous block, if you were to change the data in a block, the hash would change, creating an error that would propagate to all subsequent blocks, declaring the chain invalid. The third concept is the peer-to-peer network. One of the amazing things about this technology is the fact that it does not rely upon an external source for verification. Since the blockchain data is equally distributed amongst all of the users, everyone has a complete copy, and any new transaction is spread throughout the network to each user. Since there is no central source of the data, it's not possible to alter just one location for nefarious purposes, and this safeguards the data from attackers. This leads us to the fourth concept, which is consensus protocol. The users in the network need to come to an agreement about the validity of the blockchain before new blocks are added. This is done by using a common protocol where the nodes reach a consensus about the validity of a new block before adding it. The two main methods that are used to accomplish this are proof of work and proof of stake. Blocks that are not accepted by the chain are called orphan blocks. There are cases where there are differences in chain lengths amongst users. In these instances, shorter chains are discarded in favor of the longer one.
There are many current uses for blockchain technology, and more inventive applications are coming out all the time. A few of the bigger current uses are cryptocurrencies, smart contracts, financial services, supply chain validation, video games, voting, and giving control back to the creators of their own content. All of these applications take advantage of being able to have something digital, but also have it be unique. The biggest current use of blockchain technology is, of course, cryptocurrency, such as Bitcoin, Ethereum, Litecoin, Ripple, and others. These coins use the blockchain to create a record of transactions as outlined in Nakamoto's original paper. Cryptocurrencies have surged in popularity recently, with Bitcoin climbing in value to over almost $20,000 in December of 2017, only to fall back below $5,000, and it currently sits at $5,333.80 for one Bitcoin. Most all other currencies followed this roller coaster ride in the past few years, but they are gaining widespread acceptance. One of the most interesting applications of blockchain technology is smart or self-executing contracts. These contracts are basically made of code and define rules associated with the contract, and then enforce them automatically. The contract is set up with a triggering event, such as a strike price or expiration date, and once the trigger is activated, the contract executes and transfers the assets in the agreed upon way. These contracts also automate the escrow processes, holding assets involved so that parties are not able to spend them and default. These are most prominent in the cryptocurrency Ethereum. One of the biggest adapters of blockchain technology who's spent many resources on this technology is the financial services industry, as they see a potential to speed up back office operations such as reconciliation, accounting, and order management. As you can see, many banks and financial institutions are researching and investing in blockchain, with over 2,500 patents filed in the past 3 years, over 90 central banks discussing implementation, and $1.4 billion invested. These institutions see the potential to make business easier and to smooth the friction in many of their transactions. Financial institutions see the back office as a large expense, and anything they can do to reduce that expense amplifies their profit. So they are very excited about blockchain technology. Supply chains are another area where blockchain can have a huge impact because of its ability to create a single truth that allows multiple parties to have insight into unique assets and trust. Smart contract features also come into play with the transaction settlement and automatic escrow, but the blockchain's impact does not stop there. Although it is not widely used now, many believe that through the use of blockchain, companies will be able to enforce copyrights and trade policies, reduce counterfeiting and intellectual property risks, automate purchasing and planning, ensure compliance, and accurately track cost, enabling much easier cross-entity auditing. Now we get to my favorite use of the blockchain, games, and specifically these really ugly digital kitties. These bizarre creatures are called crypto kitties, and they use blockchain to show ownership and uniqueness. In December of 2017, these little kitties caused an all-time high in Ethereum transactions and slowed networks by over 30%. The cats are breedable and have digital DNA with 256 distinct attributes that can be passed to their offspring. One of these little buggers was sold for over $100,000, which is just bonkers. But there are other games that have interest in blockchain as well, and doing things like having unique items or characters in a massive multiplayer online role-playing games. These are just a few of the major sectors that are evolving thanks to the blockchain technology, but there are other ideas for its use out there, including blockchain-based voting systems, digital content creation platforms, and healthcare records, just to name a few. Any organization or industry that requires monitoring, auditing, and transparency across a network will in some way be touched by the blockchain in the future.
There are 3 types of blockchains. Blockchains are classified into public, private and consortium. Public blockchains are the most prominent, with Bitcoin and Ethereum being the most well-known and used manifestations of blockchain. Public blockchains have zero access restrictions, so anyone that can connect to the internet can join to transmit as well as validate data. While public blockchains are very secure, this comes with a price, because they are very slow and wasteful due to the redundancy of data. Public blockchains are best used when a network needs to be decentralized and when full data transparency and user anonymity are desired outcomes. The next two types differ from public blockchains in that they retain varying degrees of control and privacy over their chains. And because of this lockdown on any user's ability to join and to participate in these types, it's debatable whether these are truly blockchains at all, since there is a single external source that controls access. Private blockchains require permission for a user to join, and this permission comes from a network administrator, so in essence, a private blockchain lets the middleman back in. Beyond just the permission to join, there can also be restricted participation and validation access. The company using private blockchain verifies each transaction or piece of data before adding it to the chain. Since the verification is done by a single source, the efficiency and speed of a private blockchain is worlds faster than the public version. This platform has great potential to transform corporations and governments in the future. Things like voting systems could be completely revolutionized by blockchain technology, cutting out traditional barriers to voting and eliminating a lot of the infrastructure built up around it, like poll workers, counters, organizers, voting booths, etc. The third type of blockchain is a consortium. This one is partly private and partly public. It's basically a hybrid between the low trust provided by public blockchains and the single highly trusted entity model of private blockchains. Consortiums limit the verification of transaction processes to a few users or nodes instead of equally distributing that power among the entire network. A consortium platform provides many of the same benefits affiliated with private blockchain, like efficiency and transaction privacy, without consolidating power with only one company. To varying degrees, all three of these blockchain models can help to streamline organizations by cutting some middlemen in the case of private and consortium, or all middlemen in the case of the public model, out.
Well, that's it for our discussion of blockchain technology. We hope you enjoyed learning about this exciting new technology and are sure that it will touch your life in big ways in the years to come. Thanks so much.